Let's wait for 1 minute more, and then we can start the class at 6:10. Okay, so let's start today's lecture then. Let me share my screen. Is my screen visible?
Yes, sir.
so, so we were discussing linear regression. So today we will finish our linear regression topic and do notes tutorial, and then call it a day. Okay, so let's start. So here we were seeing that each of these data points, say this was x1, some x1 data point, this is x2 data point, and each of these x2, x1, we represented in a big matrix X, which was look like this. We have this x1 vector, we have x2 data point vector, and similarly there were 11 such data points. So we have x11 vector, right? So everyone was clear with this part, right? How did we created this x1, x2, x3 bar vectors? Or should I explain how did this x1 bar vector came? Everyone was okay, or should I explain this part again?
Okay, sir.
So everyone is okay, right? Not just one or two people there. Okay. So if everyone is okay, so let us write. Let's just explain this. Let me just write x1 vector. X1 bar vector was what was this? So x1 bar vector, we wrote it as x1 square, x1, and sorry, uh, x0. It's not x0 though. How do I delete this? Oh shit! Everything will get deleted. Let's take it. So x1 bar was this. X1 square, x1, and 1. So this was this x1 point. So this x1, say x1 is 2 here. Say x1 is 2. So the x1 for this point, it would be 2 square 4, 2, and 1. Okay. Say for this point, if x1 is equal to, say, call it 10, then x10 vector is 10 square 100, 10, and 1. Okay. So if there is like it's a 2-degree polynomial, if we wanted to make like say 3-degree polynomial, then the x1 bar vector will become x cube, x1 cube will also be there. So it depends upon what degree you want, but in general, it also depends on what degree you want. So linear regression. So this equation that you see, y equals to b naught plus b1 x plus u, this is a degree 1 equation, and we made a square equation. So we are trying to fit a polynomial on this data point. What we expect is that if our model learns properly, so our, okay, so let me just write what is our model. Y prediction is equal to some thetas. So theta 1, no, theta 2, theta 1, and theta naught transpose x, x1 square, x1 and 1. So if you do this thing, it becomes theta 2 into x1 square plus theta 1 into x1 plus theta naught is equals to y hat. So this is the prediction. So for given these x's, and if you can find out what these thetas are, we can fit a quadratic in this. Say assuming that this is the kind of quadratic we want to fit. But if the but since you know that the data have come from this linear equation, so we want that theta 2 should become equal to, what should theta 2 should become? 0, right? If we know that if these points came from a line, a single linear line, then we expect that if our model is trained properly, the theta 2 should become 0, theta 1 should become equal to beta 1, and theta naught should become equal to beta naught. If our model is trained properly, okay, for each of these data points, if our model is trained properly, theta 2 should become equal to 0, theta 1 should become equal to beta 1, theta naught should be equal to beta naught. Everyone is okay with this? No, yes, if you want me to repeat.
So can you explain once again?
Okay. So let's, so which part, yeah, I'm assuming that this part is okay, right? Sorry. So, so at least this part is okay. X1 bar, we are writing it in this form. Okay.
Yes,
Assume
sir.
x bar. Okay. So only this part you want me to explain. How did this become? The theta 1, theta naught became, right?
Yes, sir.
Okay. So let's see. So what I'm trying to say this, all these data points that are there, these data points, the blue dots that you see, came from this line. So beta naught, say assume some beta naught is equal to 1 plus beta 1 is equal to 2x plus some noise u, some noise, okay, some random noise. So 2 and 1, so beta naught is equal to 1 and beta 1 equal to 2, and this is what these data points look like. Okay, so for if you have x equal to 2 here, if you put x equal to 2 to the 4 over 5, 5 plus some noise, so this point is say 4.3. Okay, so it is like it came from 5, 5 plus some noise, it is like 4.3 it became. If you see this point, it is also around 2, and you see a value equal to say 5.2, and this point is 5. Everyone is, at least this part is okay, what I'm trying to say? The person who asked the question, can you see what I'm trying to say? That assume that all these data points, all these blue points came from this linear equation. The true underlying data points, these data points were generated by this linear equation. And our goal is to find, so this point, say all these data points came through this equation, but the thing is that you do not know these this line equation. What you are given is that these data points, and you want to find the underlying equation that generated these data points. Did you get what I'm trying to say? It's slightly convoluted. This line equation generated these data points, and now what I'm saying is that now you don't. Okay, so how do I say this thing? Let me try to say in a different way. Uh, mm, Assume there's a temperature prediction problem. So weather prediction, you need to predict a temperature of Chennai or whichever city you are in. So you want to predict the temperature of Chennai for tomorrow's temperature. So you know that there is some function, there is this some weather function. This is a function called weather function. If you can put tomorrow's date, it will give you the temperature. If you put today's date, it will tell you the today's temperature. There is some function, underlying some function is there that can tell you what is tomorrow's temperature, what is today's temperature. But you really don't know this function. What you know is actually the temperature of today, tomorrow, yesterday, day after, day before yesterday. All these temperature information you know. And what you want is to predict for the future temperature. What you really want is to learn this underlying function. If you can learn this underlying function, that if you put any date to this function, it can predict you the temperature. Is everyone with me for this
Yes,
point?
sir.
So what you really want is to figure out what is the underlying function, what is this underlying function of this weather, such that if you put any date there, you can predict what is the value there. Okay. So in the similar sense, assume that the underlying function is this linear equation. Assume that this is the function. Assume. And you created these data points, like these blue data points. Okay.
Okay, sir.
And now your goal is that forget about this function. Forget about this function. You just have these data points. Can you figure out the underlying function? So underlying function y hat, you write it as. So assume that, oh, okay, I don't know what this function is. I will write it as some theta 2 x square. I am assuming that this is a quadratic function. So I am assuming that it is a quadratic function. And I really don't know what theta 2 is, theta 1 is, and theta naught is. My goal is to figure out what are these values of theta 2, theta 1, and theta naught. I'm assuming it's a quadratic function. Okay, I'm trying to fit a quadratic function. If I can learn this, if my model is very good, and if from these data points, if I learn this model, if my model is very good, theta 2 should become equal to 0. Theta 1 should become equal to beta 1. And theta naught should be equal to beta naught. Can you were able to see what I am trying to say? If I can really learn this function properly, I really don't know. I want to figure out what is this underlying function that generated this data point. Then, if my model can learn really well, then it should be able to figure out these values. Theta 2 should be equal to 0, theta 1 equal to beta 1, and theta naught equal to beta naught. And then it will be able to generate this line. Is this okay? The
Yes,
person who
sir.
asked? Yeah, please do not say yes. If you feel like you are not able to follow, if something is confusing, please ask me again. I will try explaining the same thing in a different form. Because if you say yes now, the things will become even more complicated when we move into a neural network though. So anyone who has a difficulty in understanding, please stop me again. I'm ready to explain this part once again though. Anyone wants me to repeat, explain again some part, which part? Okay, so everyone is able to follow this patch, right?
Yes, sir.
Okay, so let me do an exercise now. So let's do another exercise. Say all these data points, the blue points, actually came from some function y equal to, say, x cube plus 1 plus some noise. Okay, this is the true function. So this is y true. Okay, this is y true. Assume that this is a weather prediction task, some weather prediction. So you put x value, x is like date, and it gives you the temperature. The today's temperature is 37, 35, 36. So this is the function though, which you really don't know. You don't know the temperature's function. If you knew the temperature function, then what is the point of actually doing any prediction task? We'll just directly put value. The true point is that we do not know this true function. What we really know is that from there exists some true function that these data points are generated, these blue points are generated. Now you want to write a model, say you want to predict y prediction model. What model do you think we should, what degree of function we should write this prediction model to be? Quadratic, cubic, fourth degree, fifth degree, what degree you should assume? What degree of prediction function we should assume?
The cubic.
Okay, so help me write. What should I write the prediction function? Theta, theta 3 x cube
Cube
plus
plus theta 2
uh,
x square
uh,
theta 1
hmm,
x
hmm.
then theta naught, sir.
Okay, so everyone can see, right? This is the prediction function. We do not know the true function though. What we want is that based on these blue data points, we want to estimate thetas such that we can make it a cubic function. We are making an approximation that assume that this is a cubic function, and we want to figure out these thetas. If we can figure out the thetas, we know the underlying function. So how will we figure out the theta? Based on these data points. And if we can truly learn these thetas, then our theta 3 should be equal to, if we can
0,
truly learn, equal to
0, sir.
theta 3 should be equal to 0.
Yes, sir.
Look at this true function. It is x3. What should it become? It should be 1, right? The true function is x cube plus 1 plus some noise. So theta 3 should be 1, right? There is the value is 1. X cube value should be equal to 1. This is the true function and this is the prediction function. If we can truly learn from these data points, our prediction function should be equal to the true function, right? If we can truly figure out the function from these data points, our predicted function will be equal to the true function, and theta 3 should be equal to 1, theta 2 should be equal to 0,
0, sir.
theta 1 should be equal to
0, sir.
0, theta naught is equal to
1, sir.
1. So everyone is able to see, right, that
Yes.
if our prediction function we can truly learn from the data point, it should be equal to the true function, and this is the value it should be able to tell. Okay. Okay.
Sir.
So let's now move on. So now we were all able to write any y prediction function. Y prediction function can always be written into some theta vector transpose into some point vector x bar. X bar can be a degree 3 polynomial, degree 4 polynomial, degree 5 polynomial. If it's a degree 5 polynomial, how many theta unknowns are there? Say in a degree 2 polynomial, so say y prediction model for degree 2, we wrote theta 2, theta 1, and theta naught. And we transpose, and we have x square, x, and 1. So in this polynomial equation, what are the unknowns here? This is a prediction function. What are the unknowns here? What do we not know?
Theta value, sir.
Okay, it's the theta value that we don't know, because someone will give me the value of x and will ask me to find the value of y. So if someone gives me x, I will just put x square, x, and 1, and I will just do theta transpose times x and then predict the value of y. So we truly do not know what are these theta value. We do not know What are these theta value? If someone can tell me what these theta values, I can always tell you what the y prediction value will be. Correct? Everyone is with me?
Yes, sir.
Okay. So now, so if x is in this case when it's a degree 2 polynomial, how many unknowns are there? Three unknowns: theta 2,
Yes,
theta
sir.
1, and theta naught. If it's a degree 5 polynomial, say x bar is a degree 5 polynomial, how many unknowns are there in the theta? How many number of unknowns are there in theta?
6, sir.
6. So everyone is able to see there is this one. Because of this extra one, we need to add another. So it becomes a 6. There is 6 unknowns though. Okay. So if it's a 7-degree polynomial, how many unknowns are there? 8.
8, sir.
Okay. So everyone is okay with this. Now I will never write in this vector form. I will just directly use theta transpose. So assume that y prediction is some theta vector transpose, and this, when I write small x, assume it's a single data point. It's a single data point, one data point. And y, when I write in this form, it is a one data point. Now, if you do this, it's a scalar, right? It's a vector. So theta is some, say, assume that this is n degree polynomial. This is n cross 1. And theta will become n cross 1. It's a n minus 1 degree polynomial. Okay, as it's n minus 1 degree polynomial. Everyone is okay, right? When I say it's n minus 1 degree polynomial, they are able to see this is not n degree polynomial, this is n minus 1 degree polynomial. Can everyone see this?
Yes, sir.
So when we have a x square, x, and 1, it's a 2-degree polynomial, but 3 points, 3
Yes, sir.
cross 1. So if n cross 1, it's a n minus 1 degree polynomial. Okay.
Okay,
So
sir.
so this is a theta transpose times x. So it's a vector. This vector transpose this vector will become a scalar, and you have a scalar here. So theta transpose theta vector transpose x vector x point transpose is y prediction. Now let's write for all. So this is for one data point, right? This is for one particular data point. So this particular data point. But we have like say a n number of data points. Such 11 data points are there. So let's write for all 11 data points. So we have y1 prediction, y2 prediction, and y11 prediction, and we can write it as theta transpose into capital X, and this capital X is n cross 11. Can everyone see this? What is capital X? You have,
Sir, 11 points.
yes, x1, x2, x11, and this becomes n minus 1 degree polynomial for all 11 data points. Can everyone see this thing, that the matrix multiplication will become this thing? There are like y hat 1, y hat 2, y hat 11, and this becomes this transpose. So you have theta transpose. So you do theta transpose here. So let's do theta transpose, theta transpose. So you do theta transpose times x1, it will give y1. Theta transpose times x2, it will give y hat 2. Theta transpose times x3, it will give y hat 3. And similarly, if you do theta transpose times x11, it will give you y prediction 11. So these are predicted value. Everyone is okay till this point?
Yes, sir.
So at this point, everyone is clear. Okay. Now I will do some mathematical trick though. It is just simple to this thing. Just bear with me. It will become even more. Now let's just write. it looks better if we have a vector though. I want to write in this form, ax equal to b form. Okay, b is a vector, a is a matrix, and x is a vector. Right? I want to write in this. We did linear algebra, right? Everyone is able to recall linear algebra. So we want to just write in this form. Let's rewrite this. This is x into theta is equal to y hat prediction. So your x is x1, x2, and similarly it is x11. This is what my new x looks like. And this y hat, you can think it of as y hat 1, y hat 11. Just I will wait here for a while for you to verify that this is correct. Convince yourself that can you see this is correct? So theta bar, theta vector here. So x1 bar into theta bar will give you y1, x2 bar into theta bar will give you y2 hat, x3 hat into theta bar will give you y3, and similarly x11 bar into theta will give you y hat 11. Can everyone see this thing, this equation? It just we in the previous x what we did was this transpose, and this transpose made it like right into form of ax equal to b form. I'm just now trying to write into ax into b form. Is this okay, everyone? It's just simple matrix manipulation though.
Okay, sir.
Okay, so now we know all these things, and we also know that what are these predicted value. We want these predicted value to be equal to these true y values, right? So whatever the y value is there, we want all these y to be equal to whatever the y this data has predicted. So today's, if you want to put today's temperature, it should tell me what is today's temperature. So it is zero, say 30 degrees Celsius. What is yesterday's temperature? It will tell. If you put yesterday's temperature x value, it should tell me 31 degree. And similarly, it should tell day before, like on last year's temperature. It should if I put last year's date, it should tell me that date's temperature. And what we want is that if I put any future date which we don't know, if I put that date, I multiply with theta bar and it will tell me the temperature. So what we want is that given all the data points, we also know what the prediction value should be equal to. So we want x into theta bar to be equal to this number, right? For all the dates that we know, all the dates that we have, we also know the corresponding temperature number. So we want to find those theta such that if we do x into theta bar, it should be equal to those temperature numbers. Is this okay, everyone? Is this everyone able to see that why did I make the predicted value equal to the true temperature value? We want to figure out those theta such that if I give x1, it should tell me that today's temperature is 30. If I give you x2 bar, it should tell me that it should be equal to 31 degree. If I give you some x bar 11 date, it should tell me that day's temperature. Because this data is already available. Remember that we are doing supervised learning. We know the x and the corresponding label y. We want to learn those theta bar such that x transpose into this theta is equal to y, and we want to figure out those thetas such that it is equal to these numbers. Everyone is okay with this?
Yes, sir.
If you are not
Okay,
okay, if
sir.
you're not able to follow, please ask me again. I will repeat again though. If this is okay, then we will be able to move on. So everyone is okay with this part? Anything that you want me to repeat?
Sir, as based on the theta value, the y cap will find us.
Oh, no, no, what I'm trying to say, this is y cap. I'm trying to say that we want, this is a prediction though. What we want is that we already have some data, right? These data, this blue dot, we already know the x value and the corresponding y value, right? This data is already given to us. So what we want is that figure out those theta such that if you give these x, it should give you these y's. Okay. Then the
Okay, sir.
question is that if I give you some new x, which we don't know the y of, then if our model is trained, we will just put that x into theta. It will tell me what is the y value. This is unknown for unknown x, and this is known x. So for all the known x's, we want our model to predict the known y's. So these are known x's, k xk known. I want to write it known. So we know these x's and the corresponding value of y's. So we want to figure out those theta bars such that if you put these known x's, it should tell you the known y's value. And once we, because if we can figure out these theta properly, then if I put any unknown x, it should tell me what will be the predicted value of y. This part is okay?
Okay, sir.
Okay. So now we have written this form into x into theta bar is equal to sum y bar. Look, I have removed cap here now. I am no longer using cap because this y is exactly known to us because it's from the data set itself, right? Because these data set, all these data set, we know the x and the corresponding value of y. We know the x and the corresponding value of y. We know the x and the corresponding value of y. Our goal is now to figure out these theta such that if you put these x, it will equal to the y bar. Now everyone is able to see this x is a matrix of x1 bar, x2, and similarly we have x11. So we have x is some 11 cross n matrix, and theta bar is some n cross 1 matrix, and this is x, and y bar is the true value of, what is the true value of x1 bar, sorry, y1, what is the true value of x2, y2, and similarly what is the true value of x11 is y11. Okay, so everyone is able to see this equation, x theta bar equals to y bar. So you should do x1 bar into theta should give you y1, x2 bar into theta should give you y2, x dot similarly x11 bar into theta should give you y11, and this is what y bar. So we are not writing y hat, it has become y bar now. Is that we already know the value of y, we know the value of this y, we know what the value of x's are. The only unknown is this theta. We don't know this theta. Everyone okay with this part? In supervised
Yes,
learning,
sir.
we know the data x and its corresponding value of y. Okay, so if everyone is okay with this, what is the unknown here? We don't know. Unknown is theta, right? The unknown is theta thing.
Yes, sir.
Do anyone know how to solve this equation? How do we solve this equation? We did linear algebra, right? We did it last two class before. How do we solve this? Remember this?
Theta bar equal to y bar x inverse.
Ax equal to b, and the solution was x is equal to
A inverse b.
a inverse b. So here theta bar should be equal to
X inverse Y bar, sir.
X inverse Y bar.
Y bar.
Everyone is okay with this part?
Yes, sir.
Okay, sir.
Everyone appreciate how linear regression is interesting, that you solved a quadratic equation using this X inverse into Y bar. That's it. Everyone is able to appreciate this part, at least this part, this much.
Yes, sir.
Okay, so now let's see this thing. Okay, so now I will in future I will no longer write this X is equal to this big matrix and theta this. I will just directly write X theta bar equal to Y bar, and everyone should be able to understand what is X theta. If someone is not able to understand, I will write again. But in general, everyone is able to follow. Should be able to follow now. Okay, now let's see
Okay.
this thing. Now let's see something interesting. This X matrix that we did, notice that it is a 11 cross n matrix. And remember that we told you last time that to find an inverse of any matrix, X needs to be a square matrix. It should be M cross M type. Otherwise, you will not be able to find the inverse of it. Right?
Yes, sir.
But X is it a square matrix? It's not, right? In general, it is not. It is only square when n is equal to 11. Otherwise, it is not a square matrix, right?
Yes, sir.
In general, n will not be equal to 11. We only made like 2-degree polynomial. So n will be like 3, and 11 cross 3, it will become 11 cross 3. Hence, it is not n is not equal to 11. So you cannot write theta bar is equal to x inverse y, because we do not know how to estimate x inverse now. We cannot we do not know how to invert this matrix because it's not a square matrix. So what there is very interesting thing that we will do now. So we have this equation. What we do is remember this x is 11 cross n. So let's convert into this what is it called, square matrix. So we first multiply by x transpose. We can multiply x transpose both sides, right? So we multiplied x transpose. This equation and this equation have the same solution. We didn't do anything. It's like multiplying 2 on the both side. These two solutions are okay.
Okay, sir.
We did not do any changes though. We are just doing row manipulation. We multiplied x transpose both sides. Now someone can tell me what is the size of this x transpose into x matrix? What is the size of this matrix x transpose into x? What is the size of this? Use your pen paper and tell me what is the size of x transpose x. I will wait for 1 minute.
11 cross 11, sir.
Someone said 11 cross 11. Anyone else wants to take a guess? What is another? 11 cross 11. One of you said it's 11 cross 11 matrix. Anyone else wants to say what is the size of this x transpose x matrix? Please do solve. Please participate. You will see that there are very interesting things that will it will come to. What is the size of x transpose x? Only one person? Is there only one person in the class? No, there are many people. So someone else who wants to say what is the size of x transpose x? No one?
Sir, 11 into 11.
11 cross 11. So okay, so there are two people who said 11 cross 11. Anyone else who wants to say something else, or 11 cross 11? I should just consider 11 cross 11. Okay, let's now estimate this value. So what is the size of x? It's 11 cross n.
11 cross n.
Okay, what is the size of x transpose?
N cross 11, sir.
N cross 11. Now can someone tell me what is the size of this total? When you multiply n cross 11 into 11 cross 11 matrix, it becomes n cross n, right? 11
Yes,
11
sir.
gets cancelled, it becomes n cross n. So the size is not 11 cross 11, it's n cross n. This is
Okay,
okay?
sir.
This is okay, right?
I just
Yes, sir.
math with n equal to k, sir.
Okay, so it became n cross n, right?
Yes.
Okay, so now let's do interesting thing now. So we multiplied x transpose both side. We did not do anything differently yet. And we now know that this matrix is a square matrix. X transpose X is a square matrix now. Right? It's n cross n matrix, right?
Yes, sir.
We can inverse this matrix because it is like AX equal to B. X transpose Y is just, okay, so let's see what is the, if this B is B or not. So what is the size of X transpose? N cross 11.
Yes, sir.
And Y is 11 cross 1. So X transpose Y is, this total is N cross 1.
Cross 1. Yes, sir.
Okay. So now we have a matrix. Let's call this matrix X transpose X is a n cross n matrix, and this is a n cross 1 vector. It is Ax equal to B form, right? You have A, which is a square matrix, X we don't know, and B is this vector, n cross 1 vector. Everyone is okay?
Okay, sir.
Okay. So now let's complete this thing. So you have X transpose X theta X transpose Y and the Y vector, and now we can write theta trans. So what is the solution of this? What is the solution of theta bar? How do we find the solution of from here? What is the value of theta bar?
Sorry.
Uh-huh. Guess. Try. What you know? The Ax equal to B, right? We have just converted this into Ax equal to B. Now this we have made it a square matrix. Also, what should I write?
Sir, A inverse.
So what is A here?
Sir, X transpose X.
X transpose X,
The whole inverse.
the whole inverse into
X transpose Y bar, sir.
X transpose Y bar. How many of you are able to see this? This is a correct answer though. Whoever gave this answer, this is a perfectly correct answer. And you will see that the entire linear regression, you will always see this equation. They will directly write, oh, linear regression solution is X transpose X inverse into X transpose Y. Everyone is able to see this solution. I will wait for a minute. You can think this is equal to A. This is A matrix. This is our X matrix, X vector, and this is our B. So it is Ax equal to B for, and the solution of is equals to X equals to A inverse B, and that's what she told. She helped me write this equation. Everyone is okay with this part? I will wait for a minute. Is this okay? Everyone is able to see the solution? How did we come from X into theta bar equal to Y bar to theta bar equals to X transpose X inverse into X transpose Y? Should I move? Or do you want me to wait for a while?
Okay, sir. Sir, my
Okay.
answer is right or wrong?
Oh no, yeah, this answer is correct. This answer is perfectly correct.
Okay, sir.
This is what the solution is. In any case, in anywhere you will see that the linear regression solution, they will directly write x transpose x inverse into x transpose y bar. Now you know how to derive this equation. It's just simply ax equal to b equation that they are writing.
Okay, sir.
Okay. So let's move on. So I will just delete this part and let's move. So similarly, they say that even when you actually minimize, so this is what they have wrote. They are you can also do minimizing. Other way of solving the same problem is that you want to find theta such that the distance between these two should be minimized. So this say h is some function. This is some theta bar theta transpose x, and you want to minimize the distance between some theta transpose x minus the true value of y. So remember this, see, I am not writing hat here. And you want to minimize the distance between all the data points. Say, if say xi is the point, you want to minimize the distance between these two, minimize over theta for all the data points, for all x, for all I in the data set. Everyone is able to see, and when you solve this, theta, the theta value, the theta bar value will come out to the exact same thing: x transpose x whole inverse x transpose y bar. If you minimize, if you solve this equation also, it will come out to be this value. So it's just a different way of writing the same thing. So what here we are doing is that we want to find thetas such that when you do theta transpose xi, xi is a simple one point data point. So this is xi, one data point, and it should be very close to the true point. What is the value? The true value of xi was yi. So the distance between these two should be very close. So it should be close to 0. And you want to sum over all the errors, and you want to minimize this total error. And if you minimize the total error, it will come out to be the same value that we derived before. Is this okay? It's just a different form of writing. If anyone is interested, I can go over this, how to derive, how we actually can derive the same equation from this minimization tool. But if only where people are interested, if only students are interested, that can you show me the derivation of how do you, when you minimize this equation to, you actually end up here. But it is not necessary for the class. If only people are interested, I will do this math here. Otherwise, just assume that even when you minimize this, it will come to this value. But the important part is to know that, to be able to understand that this minimization equation, everyone is able to at least understand the minimization equation though, that you want to find theta such that for all the data point xi, the distance between the predicted y hat, so this is predicted y hat, minus the true yi should be minimum. Right? It's a different.
Okay, sir.
Okay, so let's just do one last one. So this is y hat, and what this equation is y hat, and what we want is that for all the data points that we have, we want to find the predicted y hat minus the true y hat whole square. We want to minimize this. We want to find theta such that this is minimum. The square is minimum. And how do you find y hat I? Y hat I is simply theta bar transpose
Transpose
xi.
X.
Okay. So
Okay, sir.
you give me xi point, I will do theta transpose times x, I will find the yi, and that this is the predicted value. I want to minimize the distance between the predicted and the actual value whole square. And if you do this, theta bar will turn out to be exactly the same value that we derived. X transpose x inverse x transpose y vector. It will turn out to be the same value.
Sir, I
Okay.
have a doubt.
Yes. Yes.
Sir, based on the problem, we use both. Or,
Based on the problem.
sir, which formula you use for problems? Which problems?
Oh, okay, okay. So I'm saying that this is just a different way of deriving. We had derived based on ax equal to b form, right? There was a, there was b, and just we wanted to find x, and we were able to derive x is equals to a inverse b, right? This was x is equals to a inverse b form.
Yes, sir.
We found this theta based on a inverse b form, right?
Yes,
Here
sir.
we are just saying that we will not do A inverse B form. We will solve this minimization equation. I'm just saying that even when you solve this minimization equation, you actually end up coming to the same theta hat that we derived from A inverse B thing. So
Just
both
another
are
form.
just a different way of solving the same problem.
Okay, sir.
So if ever you actually want to do linear regression, there is two things that you need to decide, and there is only actually one thing that you need to decide. What is the degree of polynomial that you want to choose? So here, for this problem, you chose like say, you can choose like 7-degree polynomial. So you will have theta size 8 cross 1.
Yes, sir.
And if once you have 8 cross 1 and your x vector, x vector should be some x to the power 7, x to the power 6, and dot 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 till 1.
One.
And you do theta transpose times x bar. You have your x bar, so you construct your big X matrix. You know how to construct this big X matrix now. So you have x1 bar vector, and similarly for all the data points that you have. Say you have 11 data points, so you have 11 data points here. So you construct your big X matrix, and then the solution for this theta 8 cross 1 vector will simply become this big X matrix, x transpose x whole inverse x transpose y vector. That's it.
Okay, sir.
Okay. So there is only one thing that you need to decide: what is the degree that you want to consider in linear regression. That's it. There is entirely nothing that is not known. If you decide the degree and you can fit. So today's homework is when you go home, find any problem that you can see and try solving it using linear regression. You decide what degree you want to fit the data point into, and see if you can and visualize that. Oh, if I draw the line with this degree, is it able to fit the data point or not? Okay.
Okay, sir.
Okay. So this part is all okay, right? So it's a just different way of solving the same problem. If people want me to show how to even after solving this minimization thing, how did we reach here? We can do this thing if only people want to know how to do this. Okay, so now let's move on. So there is another thing that we also okay. So this is all okay. This is what we did. Okay, so there is this another important thing that we do. That how do we decide the degree n? Remember that I said that degree n is the one that the only unknown that we don't know is the one that you have to decide. Okay. Remember this? I told you that degree n is the one that we need to decide.
Yes, sir.
So how do we decide degree n? Is there a way that given some data point, how do we find the degree n? What we generally end up doing is that we actually look at the residual plot. So what is residual? So say for example, you have predicted this part y hat, you made this prediction. Say you made some assumption that say it's a degree. So this is assume that okay, so not this point. Assume that this point came from this degree. So all these data points came from this the red line function that I have drawn. Okay, let me just delete everything. Let me choose a different color. Blue. Okay. So all these blue color data points came from these this blue color line. Okay, this blue color line that I have drawn, it came from that. Okay. Assume that all the blue dots came from this blue color thick line, which is of a degree. Say this degree n is equal to 5. Okay.
Okay, sir.
But we really don't know that what is the degree of this. Let's just assume that we also don't know the degree of this. Okay, so it came from this function and we don't know what degree is it. So we assume that we make a guess that okay, we will start by saying that okay, let's assume that this is a degree 2 polynomial, a degree 1. So it's a 1 degree assume that this data point came from 1 degree, and you know that this is incorrect because it came from this sine type curve, which is not a 1 degree polynomial, but we are making a guess that okay, let's assume that it came from degree 1. What will we do? We will actually find all r. We will first find y hat is equal to theta hat into theta we assume that it came from degree equal to 1 part, and y hat is equals to x hat into theta. So x is equals to size is, say there are 11 points, so it is 11 cross, so it's a 1 degree, so there is only 2 unknown, 11 cross 2, and theta is 2 cross 1. Okay, so we solve this value, we solve this equation, and we find theta hat, theta bar. We were able to find theta hat based on this x transpose x whole inverse x transpose y. So we can find theta hat for n equal to 1. We assume that this data points came from n equal to 1 degree polynomial, and find out all the theta bar. You can find out theta bar once you make an assumption that it came from n equal to 1 degree polynomial. You can find theta bar. This part is okay.
Okay, sir.
Okay, so once you once you figured out the theta bar, you were able to figure you are now know the theta bar of size 2 cross 1, and now you put the same value of x's. This will give you y, not bar but hat now, because now you know what these theta bars are. You can put all these values of x's that you was there, and it will predict y hat, and then it will give you these nice line though, and you can see what is the distance between x into theta bar minus the true y, the true yi. For each xi, you can also find the true yi. What is the distance between them? You can see this thing. Now you know the theta bar. You put xi, calculate what is the predicted y hat I, and find the distance between these two. If you plot the distance, if your distance is very close to 0, like all the noise is very close to 0, if you see this kind of a residual plot, you can assume that n is equal to 1 is a perfect match. N should be equal to 1. But if you see your curve looks like this, the residual plot is y hat minus yi. This is called residual value. And if you plot all the residual value, and if you see that this very zigzag thing and a very high variance thing, it is not close to 0. That means that you must increase the degree of n. You should make it like say n equal to 4, n equal to 5. You should try with higher degree because it is not very close to 0. Why it should be close to 0? Because the difference between the prediction and the true value should be minimum, right? It should be close to 0. So it should be around this line y equal to 0. It should be around the line y equal to 0, because the prediction should be very close to 0. But if you see the prediction has very large value, 24, suddenly 29, and then it is minus 37, then you can see that, okay, the predictions are not very close to 0. It is very large. Maybe I should increase the degree of the polynomial. This is how you figure out value of n. You first make a guess. Let's say that n value is equal to 2, and then find out theta vector, which is a 3 cross 1 matrix, 3 cross 1 vector. Find the value of theta bar. Once you have figured out the theta bar vector, find the predicted value of y hat I and the distance between the true and the predicted, and plot a residual plot. If all the values are very close to 0, that means n equal to 2 is a perfect value. If it is like not very close to 0, increase the polynomial degree. Increase it to 3, 4, and do the same thing until you feel like, okay, this looks like very close to 0. This part is okay. If not, I can repeat again.
Okay, sir.
How to the thing that we are doing now is how to decide the degree n. How do we remember that we discussed that in the above formulation, the only unknown that we have is the degree n. How to find this degree n? This is what we are trying to do. So we find the value of degree n by using residual plot. Which part is not clear? Anything that is not clear? How to decide the degree n? Is how should we decide the degree n? Everyone clear with this? Amma, if you want me to repeat, I can repeat, though I don't mind repeating though, but people have to tell me whether it is clear or not.
Clear, sir.
Okay, clear? Okay, then help me solve this problem though. Okay, so you can say you started with degree n equal to 4. Okay, and you saw a residual plot and you drew the residual plot. So you, for every value of x, you find the error in the prediction, and this is the plot that you get. All the okay, so this doesn't look like correct. Say for n equal to 4, you drew the residual plot, and your plots looks like some points were here, almost all points were above, and this value is 107. 0 is here. Is n equal to 4, degree 4 polynomial fits this data properly? Is n equal to 4, the degree 4 polynomial fits the data properly if the residual plots looks like the one that I showed?
I think no, sir.
Okay, why did you think it is no?
Because the points are too away from the zero, sir.
Okay, so it is very far away from 0. Remember what we said about residual plot? What we said was that for every x point that you have, for every xi, what we did was to find the residual of this xi. Residual of xi is equal to y prediction, which is y hat of I minus yi, the true yi, the true yi. If the prediction is very good, if your model is good, y prediction should be equal to yi, and if it is very good, then it should become like 0 everywhere. For every xi that is there, it should give you a value equal to 0. If it is not good, in general, you will never be able to find x equal to 0 line, y equal to 0 line, but it should be very close to 0. It should not be like 107. If all values are 107, you know that your model is poor. It is like the error between the prediction and the true value is like so high. So the model n equal to 4 is not good. Everyone is able to follow this one?
Yes, sir.
Okay. What about, so should we increase the degree or decrease the degree? What will happen if we decrease the degree? Why increase? If we decrease the degree, what will happen? Why only increase the degree? Why decrease? Why not decrease the degree polynomial? The thing is, even if you decrease the polynomial, it will not fit well. Why? So look at this equation. Theta 5, theta 4. So I'm writing degree 4 polynomial, x4 plus theta 3, x3. I'm theta 4, x to the power 4 plus theta 3, x to the power 3 plus theta 2, x square plus theta 1, x plus theta naught. Sorry, theta naught. Right? This is correct? This 4 degree polynomial, right? Now look at this. If you decrease the degree of the polynomial, it becomes 4th degree polynomial already contains 3rd degree polynomial. If 4th degree cannot fit the polynomial, 3rd degree will also not be able to fit the polynomial, right?
Yes, sir.
Because you gave like you have all if say 3rd degree would actually fit, then theta 4 should be equal to 0 and it should be able to figure out the value. But if 4th did not fit, 4th had so much of error, 3rd will also have very high error, right? Because 4th degree 4 polynomials contains degree 3rd polynomial by setting theta 4 equal to 0. So degree 4 already contains degree 3. So if 4 does not fit, 3rd will also not fit. Will 2nd fit? When 2nd degree polynomial fit the problem?
No, sir.
No, because 2nd degree is also part of the 4th degree polynomial. Is 1 degree polynomial will fit?
No, sir.
Because 1 degree is also part of the 4th degree polynomial. So if 4th degree does not fit the data set, all the below degrees will not fit. Everyone is okay with this?
Okay, sir.
Yes, sir.
Okay. So now there is only one thing that we can do. If 4th degree doesn't fit, what should we do? We should increase or decrease?
Increase, sir.
sir.
Increase. So say if we fit n equal to 10, and now all the residual plot looks like this. If we put n equal to 10 and it became like everything here, all became very close to 0. What can we say? N equal to 10. Does it? Is this a good plot? Okay. Can you see the plot though? Okay. I feel like I made a mistake. Okay. So what I'm saying is, say for x equal n equal to 10, you made like increase, right? You said increase. So I increased rather than 5, I increased it to 10. And the residual plots looks like this. So this is x equal to 0 line. Let's change the color. And all the, oh shit, why did it change to everything? So all the I can't now write. I can't write it. So n equal to 10 and our residual plot, this is x equal to 0, y equal to 0 line. All our residual points are here. Very close to 0. Some are actually equal to 0. What can you say? Is n equal to 2 explains the data properly, or should we increase or decrease the polynomial? Or this is perfect now. We can say that the degree 10 polynomial fits the dataset properly or explains the dataset properly. Is this degree polynomial fits the data properly?
Yes, sir, because it's close to 0.
Yes, because the prediction y hat I, the predicted y minus the true yi, the values are very close to 0.
Yes, sir.
The prediction and the true values are all close to 0 for all xi's, and hence you can say that n equal to 10 explains the dataset properly. And if it explains the dataset, you can say that, okay, now give me any new point. I will tell you what is the prediction. Give me so the x bar at degree 10, which is 11 cross 1 unknown theta vector. You give me x value, give me any x, I will tell you what is the prediction for that. I will be able to do y hat, and with good accuracy, not just random. I will tell you with good accuracy, I can tell you what is the value. Everyone is okay with this? Yes, no?
Yes, sir.
Okay, now if everything is yes, now I will ask another question. Okay, so let's just delete everything. Remember that n equal to 10 fits the dataset properly. So we have this n equal to 10, degree 10, explains the dataset properly. What can you say about, will n equal to 9 also explains the dataset? Degree 9, can it also explain the dataset? No, yes. Will n equal to 9, n equal to 10, you figured out n equal to 10 gave you a residual plot close to everything, close to 0. If you have made, what can you say about degree 9? If you have made your model with degree 9, will it also be close to 0 or it will be very high?
Sir, not very high, slightly changes.
Exactly. The thing is that the degree 10 polynomial, you only know that degree 4 does not fit, but you don't know anything about, if your degree 4 did not fit, you said that degree 3 will also not fit, degree 2 will also not fit, degree 1 will also not fit, right?
Yes, sir.
We do not know about degree 5, 6, 7, 8, 9. We do not know about any of these things. What we know is degree 10 fits. So if degree 10 fits, we cannot say that 5 to 9 will not fit directly. We need to figure out if 10 fits, maybe you should go back and see if 9 fits or not. If 9 also fits, then you should go back and see the values whether 8 fits or not. If 8 also fits, go back and see 7 fits or not. And you will see that 7 does not fit. Therefore, degree 8 is the best data, is the best model that is there. It has less number of parameters and it is very simple to compute. It is easy to compute 8 degree polynomial than 10 degree polynomial. There are 2 points less. So once you figure out, you can slowly go back to see, oh, which is the best degree that fits the data set. And if 7 does not fit, 6 will also not fit, 5 will also not fit. Therefore, the answer is 8. Any polynomial greater than 8, so any polynomial greater than or equal to 8 will explain the data set properly. This is your answer, right? Correct?
Yes, sir.
Okay. So now the one last thing. There is another way too. So you know that n equal to 10 fits the data set. So you should also look into what is the value of these theta. So you have this theta 10 x to the power 10 plus theta 9 x to the power 9 plus all these numbers till theta naught. You will see that if a degree 8 fits, most are likely this theta 10 and theta 9 will become very close to 0. Say 0, 0, 0, 1. Theta 9 and theta 10 will become very close to 0. Then you can say that the contribution of from this and this is anyways very minimal. It is a 8 degree polynomial, may be able to explain your model properly. You can also say from this thing too, right? Can you see this thing what I'm trying to say?
Yes, sir.
Okay, so I think today, yeah, that's what it is. It's now they are talking about differently size plotting. So the problem sometimes becomes that why you should always try decreasing is now. This is the last topic that I will do, and then we will call it today's day. I thought that today we will actually do tutorial, but I thought linear regression took so much of time. One last topic. So remember that we saw that n equal to 10, we said that it fits the data set properly. And I asked you that you should go down though. You should check n equal to 9, n equal to 8 and 7 and 6. So you saw once you checked and it's figured out 7 does not satisfy. It did not explain the data set properly. So all the below will not explain the data set. And n equal to 8 gives you it explains the data set properly. So you chose n equal to 8. Why you should not choose higher degree is because look at this thing. The this is the price curve. Which among these plot explains the data set properly though? Which do you think explains the data set properly? Do you think 1 degree explains better, 2 degree explains better, or 3 degrees, third degree, or fourth degree explains better? Which one is a better plot? Like if I give you a new point here, or say if I give you a new point here, so it predicts this value, and for this new point it predicts this value. Which one? Which and for this point it predicts this value. Which one do you think is a better prediction? Option 1, option 2, or option 3?
Sir, I think option 2.
Option 2, sir.
So everyone can see that option 2 is a better prediction because it is, look at this prediction. It is just directly trying to fit every data point that is there. So if I have like a data point here, it will do this. If you have a data point like this, it can predict you this value. It is fitting the data point, but look at the values that it is actually trying to do. It is trying to fit every data point that is there. So the higher degree may fit the data point well, but it is not a good explanation though. You should always try to figure out what is the least number of degree polynomial that should choose such that it best explains the data set. So this part is called overfitting. So higher polynomial degree things can overfit your data set. So you don't want your data set to be overfitted. Like how do I say overfitting is like you have trained yourself so much for this one single problem that you cannot solve any other problem. And this is not what you want. You don't just want that I should be able to tell you the correct answer for tomorrow's temperature, today's temperature. What you really want is that what is the future temperature? This is what you really want to predict. So it should not overfit the data set. So higher degree polynomial may overfit the data set. What you should always do is prune the degree, go lower. And if you figure out that this is the lowest that best explains the data set, then report that point as the best fitted model. So that point, and degree n equal to 8 is the best model. This is the correct model. N equal to 10 is overfitted model. Overfitted. So it is not good. So you report n equal to 8. Everyone is okay with this?
Okay, sir.
Okay, sir.
Okay, so I think today I will just stop, and tomorrow we will do tutorial though. So I think today we do not have enough time. Yeah, so this finishes our linear regression. So tomorrow I will do a linear regression notebook and tutorial, and then logistic regression math and all the proof that we did. So everyone is okay with this, all these part? Any
Okay,
questions? We only have 1 minute though. I did not leave for anything for question. If any question is there, then we can take this now. Okay, so it seems no question then. So we can end today's class, and tomorrow we will do linear regression notebook. Thank you, everyone.
Thank you, sir.
So let's end the class today. Thank you. Bye and good night.
Thank you, sir.